Alrighty, hi chemistry. Alright, so I'm going to do some naming and writing of chemical compound problems for you today. Right now I am on page 14 in your nomenclature packet, and you see 5 problems that are right here I'm going to take you through, okay? All along the way I'm going to be using the nomenclature flowchart when I need it. I'm going to be using a periodic table, and I'm going to be utilizing your ions list, right? And I'll be referring to those documents accordingly as needed. All right, so ammonium cyanide. So the first thing I always do, right, is I write down what I have. So ammonium is found on your common polyatomic ions. It's the only metal, it's the only positively charged one, and it's right here, ammonium. And so ammonium is NH4. Now, I don't want to put the charges with the formula because I just think it gunks it up and makes it messy and what have you. But what I usually do is I'll put it over the name. And if we look on this chart, all right, our polyatomic ion sheet, it said +1. So ammonium is looking to give away 1 electron. Now, cyanide. Cyanide is also a polyatomic ion, okay? And it is the polyatomic ion with the formula of Cn. Okay, Cn. It carries a -1 charge, meaning it's looking to gain a negatively charged electron. As such, 1 electron transfers, 1 electron is gained, and therefore it's happy. So 1 ammonium, 1 cyanide, and that is the correct answer. The second problem, okay, this is the first time on this page. So that was an ionic compound where we had a transfer of electrons. This one's different, okay? This is a covalent compound. How do we know that? There's no metal in it, right? Hydrogen and oxygen, there's no metal. And so the prefixes that are here help us quite a bit, di and mono, and then the elements are given to us as well. So really on something like this, it's pretty simple. Look at prefixes, look at the element, and record them. So on dihydrogen, well, hydrogen is H. Di means that there is 2 of them, that's H2. Oxide means oxygen, mono equals 1. I'm not going to write the 1, it's redundant to do so. This is just water, H2O. Copper 1 hydroxide. All right, so copper is a metal, all right? It is element number 29 on the periodic table, so it is a metal. It's a transition metal, and how do I know that? I know that a couple ways. One, I know from where it was located. But the second thing is I have this stock name. And so the copper charge is going to be +1. Hydroxide, okay? Hydroxide is OH. If we go and find that on our sheets, okay? It's right on our polyatomic ion sheet. And hydroxide is -1. So therefore, again, just like in the first problem, +1 and a -1. We have 1 electron being transferred. Cu, 1 of them. Hydroxide, 1 of them. CuOH is the proper way to write it. All right, cesium permanganate now. So, cesium is a metal. It is Cs. And where cesium is on the periodic table is it's in group number 1. Okay, so cesium is right here. Everything that is in this first group has 1 valence electron, therefore all of them are +1. 2 valence electrons, so all of the alkaline earth metals are +2. We come across, right here, we have +3, plus or -4, -3, -2 for the chalcogens, -1 for the halogens, and the noble gases have an oxidation state of 0. All right, so in this case, +1 again. Permanganate. We go and find permanganate on our ions sheet. Permanganate is MnO4. MnO4. And then what you would do is you would then look up what the charge is of permanganate. It's towards the bottom of our pages here. It's right, the second one up. And so it's -1 as well. Okay? And so we have +1, -1, and again, that just kind of works. Number 5, I need you to make a slight change on your packets. It's not written correctly. It should read pentafluorine. We never changed the element first name. So notice here it was hydrogen. Notice here it's fluorine. So when we have something that is a covalent compound involving prefixes and no metals, we always have the name of the first element unchanged. And so that should say pentafluorine. I would like you to change that. All right, so fluorine is F. Penta implies that there are, indeed, 5 of them. Okay? Bromide is the element bromine. That's symbolized by a Br. And deca means we have 10 of them. So this is F5Br10. Let's do one more problem on this page. And the biggest reason I want to do one more problem on this page is because I want to do one where it's not like 1 and 1. So let's do number 6, okay? So number 6 reads sodium phosphide. So sodium phosphide. Give me 1 second here. Sodium phosphide. All right. So sodium is a metal, okay? Sodium is located on the periodic table, also in group 1. And so this one also has a charge of 1, but the phosphorus doesn't. So that's why we can work with this. So sodium, we write the symbol of Na. It's a +1 charge. Phosphide, the fact that it has an "ide" ending means it's monatomic, meaning it came from one type of atom, and that one type of atom are phosphorus atoms. Now, if we go find phosphorus on the periodic table, it's right here, okay? And nitrogen and phosphorus and arsenic, these elements right here, they have an oxidation state of -3. So what this means, right, is that one electron is being transferred from sodium to phosphorus, but phosphorus isn't happy about that. Phosphorus says, well, that's not enough for me. I'm looking for 3. And so what it says is, but sodium, if you can go get another sodium and go get another sodium, then what I'll do is I'll take 1 from that sodium, I'll take 1 from the second sodium, and I'll take 1 from the third sodium. And so how many NAs or sodiums did it take? It took 1, 2, 3 of them. That's why this is Na3P for an answer. Now, go across, straight across from that, where you see number 16, all right? Number 16 now. Number 16, okay, is iron 2 nitrite. Well, let's talk about a couple things that are in here. We have a stock name that's in here, and we also finally have a metal that is not +1 charged. All right, so iron. Iron is Fe. It carries a +2 charge. That's what the 2 in parentheses tells us. Nitrite, we go find that on our ion sheet. And what we find for nitrite is it is NO2, and it carries a -1 charge. So, right here, we have 2 electrons looking to be given away, don't we? But nitrite is only looking to gain 1. So what nitrite says is, okay, we'll go get another nitrite. One of them is gained by that nitrite, one of them is gained by it, and both of the iron's electrons are gone, so iron is happy. So we need 1, 2 nitrite. Well, we can't put a 2 right here, because if we did that, then we would end up with 1 iron, 1 nitrogen, and 22 oxygens. And we need, 1, 2 nitrites, don't we? So how do we ensure that? What we do is we put a parentheses, and now this gives us 2 NO2s, okay? And so this is Fe parenthesis NO2, 2. I'd like you to complete the rest of this page. Pause me and do that. All right, now I am on page 15, and I got 6 problems I'm going to do here. Now we have a chemical formula, and from that chemical formula, I'm going to ask you to give me its name. All right, so here we go. So again, I'm going to be utilizing the flow chart. I'm going to be periodic table, ions list, right? All right, so here we go on this first one. So anytime we want to give a name to something, what we're going to do is we are going to ask ourselves a question every single time, okay? Does the compound contain a metal? Okay, every time. Don't skip the question. And K, potassium, which is right here on the periodic table, is way over here, right? So as such, yes, big time a metal, all right? And so therefore it contains a metal. Our next step is that metal K a transition metal? The answer is no, okay? So therefore we just put its name. The element's name is potassium. Now, after that, we stay on the yellow brick road and we say to ourselves, we go to our anion question. And the anion, after the metal, and it doesn't matter if there's two of them, right? The only reason there's two of them is because we needed a +1 and a +1, right? To be able to account for the -2 charge of chromate, right? But this is just potassium, okay? All right, and so then we continue along. Is the anion polyatomic? It says right here. And the answer is yes, okay? CrO4 is the chromate ion, okay? So if it is, then we just put its name. So the answer to this is potassium chromate. And it's literally that easy, and don't make it more difficult than that. All right, here we go. Second one. Does the compound contain a metal? Sulfur? Nope, not a metal. Fluorine? Not a metal. Therefore, the answer is no. Is the first element hydrogen? Again, I'm just following along on your chart where the answer was no. Is the element hydrogen? No. We finally have permission to use a prefix system. All right, so for the first one, sulfur, okay, what we do is we never put mono. It's one of our rules, like we talked about with carbon dioxide, right? And so we just write sulfur. We don't shorten the first element's name, sulfur. The prefix for 6 is hexa. And fluorine, well, on this we do change the ending to an "ide" ending, so this becomes hexafluoride. All right, right here, MO. This is an odd element. It's not one we see all the time, but it's element number 42 on the periodic table. It's right here, okay, in the center. And so element number 42 is molybdenum. So we ask ourselves, does it contain a metal? The answer is yes. Is it a transition metal? The answer is yes. And so because of that, we have to give this thing something called a stock name. And so what we do is we write out its name, and its name is molybdenum. And then what we do is we put a parentheses, and we're going to figure out the charge that goes in that parentheses in just a second. For now, I want you to write the NO3 part out. Let's look at NO3. NO3 is it a polyatomic ion? So you're asking yourself that question again, and the answer is yes. Therefore, you put its name. And so NO3's name is nitrate. Now, we still do have this question hanging over us of what is the charge that belongs right here, and here's how we figure it out. According to the chemical formula, we have 2 NO3s, don't we? And nitrate, if you look on the ion sheet, is -1, and we have 2 of them. So we have one that's a -1 and a second one that's a -1. Now, molybdenum, the fact that it exists means that there is one of them, right? And we don't write in the ones, but you could. And so what would one molybdenum have to do to be able to give an electron to that nitrate and an electron to that one? It would have to be responsible for both of them. And so therefore, this is molybdenum 2 nitrate. Now I ask ourselves, okay, common name. Right? If I can, I have to give a common name. And in this case, there isn't one, so we don't have to give it. That's different from up here, number 4, okay? Number 4, does the compound contain a metal? Yes. Is that metal a transition metal? Yes. All right? It's not in the center of the periodic table, but tin and lead are exceptions to the rule. And so PB is a yes. All right, so we have to give a stock name first. So I'm going to write in lead. I'm going to put a parentheses for the charge. And then from there, ClO3, is that a polyatomic anion? Yes, therefore we give its name. ClO3 is chlorate. All right, now we got to figure out what the charge is that belongs in the parentheses. Well, we have 2 ClO3s, so just like on the last one, chlorate is -1, okay? We have 2 of them, so it's a -1 to -1. Therefore, my 1 lead must be the +2 version. This is lead 2 chlorate. Now I ask myself, okay, that's the stock name. Does it have a common name? Well, I come look on my ion sheet, and under Pb+2 is plum bus. So instead of lead 2, it could also be said to be plum bus. And this part stays the same, so it's plum bus chlorate. For number 5, okay, Sn, does it contain a metal? Yes, it does. Sn is a metal, it's tin, okay? Is tin a transition metal? We just said tin and lead are honorary transition metals. So the answer actually is yes. We have to give a stock name and maybe a common name. And so we write out its name, which is tin. We put a parentheses right here. MnO4, we have 4 of them, and MnO4 is -1 charged. So therefore, 1 -4, 2 -4s, 3 -4s, and 4 -4s. Because we have 4 MnO4s. That's a -4 charge. My 1 tin is +4. Therefore, this is tin IV. And MnO4 is permanganate. Permanganate. All right, and the last one, S3F9. S3F9, okay. Does it contain a metal? No. Again, sulfur, no. Fluorine, no, just like it was over here in number 2. Therefore, not hydrogen at the beginning. Therefore, we can use prefixes. So, 3, the prefix for 3 is tri. We put the element's full name, sulfur. For number 9, that prefix is nona, kind of a weirdo. Nona, and F becomes fluoride. I'm going to write so that I don't lose you off the screen, I hope. Nona fluoride. Okay? Let's see. I think we're doing okay here. I hope you're doing all right at home and sticking in there with us and doing all right with it. So I want you to keep going and, keep learning about chemical compounds. All right, naming and writing of them. One last thing, one last topic that will come at us is acids, and after that, you'll know all your naming rules, and then you'll just be able to become experts on nomenclature. Good job.